This video contains the solution for problem number 1 on the AP Calculus BC exam from, I think, year 2008. And here it is. I'll figure that out in the title of the video. That's what we're looking at. So let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x, part of a cubic, as shown in the figure. Find the area of R. Well, let's see. Area is the integral of the top one minus the bottom one. This is not volume, so I don't have to square anything. It's just the top one, sine pi x, minus, being careful with parentheses here, minus the bottom one. And we can see very clearly from the graph that they intersect here and here. So from 0 to 2. Sometimes we have to find those intersection points with our calculator, but not here. And if you put that in your calculator, you should find an area of 4 square units. They didn't give us anything, so they're probably just looking for area equals 4, but square units on there for completeness. That's part A. This is calculator part, so probably looks like, 4. That's a nice answer. We could have done that by hand, but it would have taken a lot more time. Now, in part B, we have a horizontal line, y equals -2, splits the region R into 2 parts. They want us to write, but not to evaluate, an integral expression for the area of the part of R that is below this horizontal line. So, that part right there. Well, I think now I need to find these intersection points and then find the area of that minus this, right? It's another area. So with my calculator, I'm going to go ahead and we want to find where is -2 equal to, which function is this? This is intersecting the, clearly the bottom one, the cubic, which is x cubed minus 4x. I need to find, this is where the intersection points are equal. That's from setting y equals to -2 equal to this. And with your calculator, moving the 2 to the other side, plus 2, finding the zeros, you should find that the intersection points are at x1 equals 0.539 and x2 is equal to 1.675. So that means the area, it's the area from x1 to x2. And did you know if you label things like this, you can write your answer like this as long as you have clearly marked what those refer to, what x1 and x2 refer to. So they will take, that's perfectly acceptable as an answer. And then I need the top function minus the bottom one. The top one is actually the -2 and the bottom one is the cubic. So that's -2 minus x cubed minus 4x dx. Remember, this is not volume yet. We're just finding an area, so nothing's getting squared, no pi's on the outside, just area. Part C, the region R is the base of a solid, that whole region. For this solid, each cross-section perpendicular to the x-axis, so we're slicing this way, is a square. Find the volume of this solid. So each cross-section is perpendicular to the x-axis, like this. Let me pull those out, and they're squares. So what's the side of one of those squares? Well, the side of each square would be the top function minus the bottom function. So that is, top function is sine pi x still, minus 4x, minus x cubed minus 4x. That's what the side of a square is. So the area of the square is that whole expression, sine pi x minus x cubed minus 4x squared. And since we're doing cross sections, again, we're just doing the integral over the whole stretch, which is from 0 to 2, of the area. If it's a rotation, then the area is pi r squared. That's where that formula comes from. So we're trying to find the volume, so we're going to evaluate with our calculator this integral, the integral from 0 to 2 of this area function dx. That's that function. I'm not going to put that in again. Now be very careful with your calculator. Make sure you keep track of your parentheses. You should get an area of 9.978, or sorry, a volume. This is a volume. And that would be units cubed. You probably don't need that. There you go. And part D. Last part. The region R models the surface of a small pond, and at all points in R, a distance x from the y-axis, so a distance x from the y-axis, the depth of the water is given by h of x is equal to 3 minus x. Find the volume of water. Well, this is like a cross-sectional one, too. For every slice now, for every slice here, pull this out, this dimension right here is still sine of pi x minus x cubed minus 4x. But now they're telling us, that's this dimension, right? The depth here is 3 minus x. Right, the depth of the water. So that's like the height of the rectangle, if you want to think about it that way. Depth, height, same thing. So that's 3 minus x. So the area of that rectangle now, as a function of x, is this expression here. Oops, I forgot a parentheses there. It's 3 minus x times the sine of pi x minus x cubed minus 4x. That's the two dimensions of the rectangle. And then we need to find, again, the volume integrating across the whole area from 0 to 2. And using our calculator, being very careful again, we should find a volume of 8.370 cubic units.